We're running a questionnaire parsing challenge where you can win up to £1,000 in vouchers, and the topic of the challenge is to improve Harmony's questionnaire parsing. So just to demonstrate what that means, if you go to harmonydata.ac.uk and click Try Harmony, you'll see that Harmony has the functionality where you can upload a PDF. And here's an example of one of the PDFs. So we've got a PDF questionnaire, and the questionnaire texts are here in this table. It's a non-trivial task to get Harmony or any computer system to parse these questions out and remove, for example, boilerplate text and the copyright and the disclaimer at the bottom. So at the moment, if I drag and drop this example in or upload it, we will see, let's upload this one. You'll see that Harmony can find the questions in some way. So in this, for this file, it does seem to be working more or less. However, for many files, it doesn't get the correct values. So we want to train a machine learning model, which would ideally be a named entity recognition based model, probably using a library such as Hugging Face. To improve this process in Harmony, we have provided a training data set, and we have our own evaluation data set, so you can test everything out. You can submit your model to this platform, Doxa AI, and it will be evaluated, and you'll get a score, and you will appear in the scoreboard. So we've already got quite a few people in the scoreboard, which is great. So how to get started? If you go to the Doxa AI competition page, there is a Google Colab notebook. And if I run this Google Colab notebook, so let's do some installations. We're going to install Hugging Face transformers. This takes a while. And we're also going to install the Doxa CLI. So this is software made by our partners, Doxa AI, which is doing the evaluation of your model on a remote server. So I'm installing my third-party dependencies. That's running at the moment, and in a minute that should be all sorted. Okay, so now let's install the Doxa CLI, and okay, we've got our message for to restart the session. And let's download our data sets. So we've got some training data sets that have been prepared by the Harmony team. This is manually annotated. So let's have a look at some of it. So you can see there is a tagged version where everything is tagged as, for example, A, Q, or O. Also, A and Q. So A is a question answer, and Q is the question text. And then we've got the clean training text that corresponds to that, which is untagged. So, and then there's also a set of labels which have the character indices. So then we're going to use this interval tree library, which will allow a quick lookup to work out if a particular character index is in the range of a question or answer. Now we're going to import the Hugging Face tokenizer. So this is what we're going to use as the first stage of the named entity recognition model. We want everything to be tokenized, i.e. split into characters, and there are a number of different tokenizers. You could use your own tokenizer. It really doesn't matter, but this example is using the Hugging Face tokenizer. And let's give every character type a label. So every character in our entire document is going to be either other, question, or answer. And we define the meta the parameters of our model, of our tokenization, and let's create a Hugging Face dataset object. So this is just turning everything into the Hugging Face language, essentially. And now let's print out some of the tokens that are in our dataset. So you can see each token has the token text, character indices, and the label assigned to it, which could be other or answer. Okay, and now we start our token classification model, also known as a named entity recognition model. We're going to start from this one Distilbert base uncased as but you could choose your own one. So I highly recommend when you're entering this competition, you go on Hugging Face, or even you can look in other ecosystems other than Hugging Face, find other LLMs to start with. You could start with your own LLM. You don't even need to use an LLM at all. You can use a more traditional named entity recognition model, such as conditional random fields. And okay, and now we've created our model. Let's start the training process. So this part is going to take a while. So you can see the green cursor is on trainer.train. So we're now training. This is going to take a while. Obviously, if you have a higher spec machine, this would run faster. You don't need to run on the Google Colab at all. You can run on your own, or you could even have a paid Google Colab or AWS or Azure account where you have a higher spec, and this would run much faster. You would also ideally run for more epochs. When you're entering the competition, you can play with all these values, such as the weight decay, the learning rate, and so on. So basically, this is your hyperparameter space. So hyperparameters, you can vary the model that you're fine tuning, which is the Distilbert. You can vary, all these numbers here: batch size, number of epochs, and you can even just go entirely outside of this framework and use your own choice of model or library, or you don't need to use Hugging Face necessarily at all. Although Hugging Face is advantageous because ultimately we do want to deploy what you train in the Harmony web app, and that web app is already using Hugging Face for the vector calculations and the cosine similarity between items. So ideally, if you don't, if your solution doesn't involve the introduction of more third-party dependencies than necessary, we're more likely to be able to implement it into the web app which people are using. So I'm going to fast forward here. Okay, I'm stopping the training because it's just taking a bit long. So now we can just run some evaluation of the model. So in practice, you would have let it train a lot longer, and you can see this is when you give an input to the model, it categorizes tokens as other, or as question or answer. And now let's save our pre-trained model. So we're going to save it to disk on Colab, and we can now log into Doxa. So I have to open a URL, a third-party URL, sign in, and give Colab access to Doxa. And now we can just upload my submission. So Doxa is going to evaluate that. It will take maybe 5 minutes for it to be evaluated, and my score will appear in the scoreboard. can see the upload is still happening. It's got to upload this LLM to the Doxer server. And there we are, it's been uploaded. So this is the scoreboard at the moment. So I'm not currently on the scoreboard at all. So I'm going to watch this for the next few minutes and hopefully I'll appear on the scoreboard. And now 2 minutes later, I've refreshed the page and you can see I've appeared in the scoreboard.